Let's go to equal 2616. Minimize the maximal differences of pairs. So it give us the integer real numbers, and also we want a number p. We want to find p pairs of numbers. We want to for each pair, it has a difference. We want to minimize the maximal difference of these p pairs. So we say that this p pair we cannot have overlap. That means, for example, if I have a number A, it has used to be um, a pair with B, right? And then B cannot use B with C. So that means um, every pair can only be used. Every number can only be used in one pair. So for this question, let's think about how to choose the pairs. Apparently, because we want to minimize the maximal, so for these p pairs, the things that I want, what I want is that I want to get those kind of numbers as close as we can, so that the pair has a minimal and the difference will be kind of small. For example, if I have an index at here and I plus one, and the index I plus two. If I plus two is this number, right? Apparently, when we choose a pair, I and I plus one will be better than I and I plus two, right? If this is big. So, so this question, it is like choosing choosing, for example, in the n and trying to see whether we can find the p pairs um, and find the minimal differences. So that means that because we want to find um, the differences, get the differences, p pairs differences as mean as we can, right? So the things that as we know, we always want to choose those pairs which has numbers to be as close as we can. So we can sort these numbers first, right? So if we sort this, then this kind of numbers is, for example, in ascending order. Then we try to say choose p pairs. So now we still have p is have 10 to the power 5 time range, right? So to brute force to choose p pairs still not good idea. So the things that we can think in this way, that for example we want to minimize the max, right? So that is if we want to see there is a range, a limit, right? A limit, trying to see for this limit whether we are able to choose p pairs. So if we are able to choose p pairs, that means if we are that there are more pairs then we can choose if we set a limit at this, right? So that means we can set a limit smaller, because when limit is greater, right? So we have more freedom choices. So that we can thinking about doing the binary search. So binary search is we binary search this kind of limit. So that if we binary search the limit, if we can't return to p pairs, right, then that will be our result. So for example, we have a limit t, right? So how can we count the pairs? So now if the numbers already being sorted, what we do is that we see the first and the second number, right? So if this one is smaller than t, then we can add one pair, right? And in this case, we can move to I plus 2, right? And apparently, in this case, even for example, I plus 1 and I plus 2, they also small, difference is smaller than t, right? It is better we choose I and I plus 1 because we can have the index as left as we can, right? So, so that if we have choose one, we have one pair is smaller than t, then we have I just increase to I plus 1. If it's, for example, this one, I and I plus 1 is greater than t, what we are going to do is just move this I to I plus 1, trying to compare this I plus 1 and I plus 2, right? So that if our total counts is greater than p, that means we can still boundary search on the smaller limits until we find the limits, right? If it's smaller than p, then we that means we should get the limit to be larger, right? So after this analysis, we can write code. Um, so the things that as we talk about, we need to sort the arrays. Then we're going to have int I equals nums dot length, and we are binary search. So we'll see those kind of limits. The if all the number they are same, right? So that means we can have the start to be 0 and end because it is sort, right? So we can have the largest and the largest number minus the minimum number. So we'll see because this p is smaller than 2 n over 2, right? So that means if we have n nums n minus 1 minus nums 0, we'll always have at least p pairs, right? So then what we'll do is that we are going to have a binary search y start plus 1 smaller than n. Then we're going to int mid equals start plus n minus start divided by 2, right? So we'll say if can have p pairs, so we have nums and mid and p, right? That means we can get a smaller, uh, get this kind of min max smaller, right? So that means we can have n equals mid. If else we cannot count p pairs, then we'll have start. We will have to have the min max larger, right? So in the end, because we want to check the minimum value, so we will write if the start satisfies the conditions, then return start. Then return start. For this question interval will always have value. So if start doesn't satisfy the condition, we just return n. So we write the help function boolean and find the p pairs. P pairs. So we'll have int nums int p and target, right, in this limit, and then also int p. So what we do is that when you have a count equals to 0, right? I equals to 0. Um, and let's have n equals to nums dot length, right? So we are going to for we'll use while while this I plus 1 is smaller than n, right? So if nums I plus 1 minus nums I is smaller equal to t, right? For smaller equal to this t, this counts, this limit, then we'll have count should increase by 1, and then we can have I goes to I plus 2, right? Should plus equal to, and else we just move I increase one index, right? So in the end, just return count is greater equal to p, right? So we'll see the time complexity. It is a binary search on this result, right? So if this is biggest number and the smallest number is the difference, for example, is D, right? This will be O n log D, right? And this one is a sort is n log n, so it is n log D plus n log n, right? So so that is time complexity. And the space is a constant. We can also write um, Python code for this. So we need a sort nums sort, and we're going to have start and equals 0 and nums -1, right? We can use -1 and then nums 0. So let's say while this kind of start +1 is smaller than n, we're going to have mid equals start plus and divided by 2. So let's say if self can p pairs and the nums and mid and p, right? Then we're going to have can get this limit to be smaller and equals mid, else we're going to have start equals mid, right? So after this while we check if can self that can p pairs nums start p, then we're going to return start, otherwise just return n. So for the binary search, for the count, the depth the KMP pairs, right? KMP pairs. So it going to we are going to have the parameter nums. This is the list of int, and t the limit is the integer, right? And also p pairs. This is trying to see whether we are able to get p pairs. So it will return Boolean or. So what we do is that we are going to have count um I and n, okay, equals 0 0 and length nums. So what we do is that while this I plus 1 is smaller than n, we're going to have if nums I plus 1 minus nums I is smaller equal to t, then we'll have a count should plus equal to 1, right? And I should increase to I plus 1, right? And else, just so we have I should plus equal to 1, right? And return its count is greater than p, greater equal to p, right? Can p pairs